Hello everyone, welcome to our next video, our next lesson. In the last video we learned how to draw the graph of a sine function. We basically got the y values, we made a table of values, 5 points were put in it. Getting the y values were pretty straightforward, they were relatively simple. Calculating the x values was a little bit tricky, wasn't it? Okay. Um, Remember that when we did the graph, the sine function, I want you to remember very carefully. Let me just make a set of axes right here. The sine function, remember, goes through the point 0, 0, and it basically kind of looks something like that. It leads into a maximum a little bit to the right and a minimum a little bit to the left. That 0, 0, that was our starting point for the sine function. And when we calculated the displacement basically told us how far that point, that 0, 0, that starting point, how far it moved to the left or how far it moved to the right. Now, the cosine function is a little different because remember we said that for cosine, let me just come down here, the cosine graph does not go through 0, 0. It doesn't go through the origin. In fact, the cosine graph, its y-intercept, is approximately right there. It's at a maximum. It's at the point 0, comma 1. And then your cosine graph basically kind of goes down like that on either side. And you can keep going to the left and keep going to the right, and you'll get your wave, your curve. All right? When we graph the cosine function, this is our starting point now. We're going to actually be starting out, your very first point is going to be a maximum. And if you look at the graph they've got there on page 27, this would be your point number 1. You see, we start with a maximum. We don't start with y equal to 0. It's not halfway through the curve like the sine graph was. The cosine graph is going to start at whatever the amplitude is. So it's going to start with your max. That's your point number 1. And again, whatever the displacement is, that's your first x value. The second y value, that's going to be halfway down your curve. That's going to be, it's the amplitude from that point up to the max. So the second y value is 0. The third point, the third x value you're going to get, or third y value, sorry, that is your minimum, isn't it? That's the negative amplitude. The fourth point you're going to get is back to a 0 right there. And finally, we leave off, the last point you're going to be graphing for your cosine function is another max. All right, do you see that? So that's what's different essentially between the sine function and the cosine function. It's not the x's. You're going to calculate the x's in exactly the same way you calculated the x's for a sine graph. That's not going to change one bit. But what is going to change are these points you see right here, the y values. That's what's going to change. And that's the only thing that's going to change. So if you look at this table down here, you even get the distance between your x values in exactly the same way. It's still the period divided by 4. So here's the table that you're going to be creating for cosine. But the only thing that's different is the y values. Look, it starts with a max now. Then it goes down to 0, down further to your minimum, then up to 0, and finally up to your max. But that's the only thing that changes. Amplitude 0, negative amplitude 0, and amplitude again. But the x's are calculated in exactly the same way. And if you remember that, then you'll have no trouble knowing what to graph. The main thing is you look at your equation very carefully and you make sure that you see the word sine or you see the word cosine. Here's example number 3, and this is on page 28. So let's try this one, shall we? Let's try page 28. Now again, I've got a real problem with the scaling that they've once again used here on your graph, because you can see here's 0. Here's pi over 2, and here's pi. Here's 3 pi over 2. What in the world are all those values in between? What are they? You might be coming up with x values here in your table, and you might be wondering, where are they on my graph? And again, I'll stress that that's why when I give you a test or a quiz, when you're asked to draw a graph, I'll make sure the x values are shown nice and clear. But here they're not. Well, that's okay. I'll tell you what, let's figure it out what they are. Let's figure it out. What does each one of those blocks on the x-axis, each one of those intervals, what does it represent? And the easiest way to probably figure that out is start here with 0. Okay, look at that. There's your 0. That's x equals 0 right there. That's 0 radians. Now, let's go to the right. Let's go up, up, up until we hit that right there. You see that? There's pi. There's pi. So 0 up to pi. How many intervals or how many blocks have they divided that up into? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So the distance on this graph, on this x-axis, between 0 and pi has been divided into 8 equal pieces or 8 equal blocks. So what that tells me, everybody, is this, that each block on the x-axis, the scaling that they're using, is equal to pi over 8. Now you remember that. You remember that as we're coming up with our x values and our points and we're plotting them down here. Each block here is pi over 8. And so what that means is, let me just erase this. What that means is, there's your 0 again. So there's pi over 8. There's 2 pi over 8, which reduces to pi over 4. There's 3 pi over 8. The next one is 4 pi over 8, which reduces to pi over 2. Look at that. 5 pi over 8, 6 pi over 8, 7 pi over 8, and 8 pi over 8. Well, 8 over 8 is 1, so that gives us 1 pi. So that's what the scaling is. Remember that now when we finally come back to this and actually have to draw our graph. Okay, so let's go back up here now. Let's see if we can fill in that table. Now remember, you're better off putting in your y's first. And this is most definitely a cosine function. Look at that. So that will start with a max, and then a 0, and then a min, and then another 0, and back up to the max again. And the max, of course, and the min is just a positive or negative amplitude. The amplitude, according to our equation there, that's the number right in front of the cosine, you see? So your A is 2/3. 2 over 3. And I've noticed in the graph down below, they did scale that one pretty good because you can see from the y values the distance from 0 up to 1 has been divided into 3 equal blocks. So at least that's nice. They got that done nice. So 2 over 3 would be right up to there. You see? There's 2 over 3 for the y value. And if you go down 2 blocks out of 3, there's your negative 2 over 3. So at least we don't have to be guessing that. All right. So let me see. So the amplitude is 2 over 3. So the y values are going to start 2/3, and then it's going to be a 0, and then it's going to be a negative 2/3, and another 0, and it's going to leave off with a 2/3 once again. There's your y values. Now, the other ones, the x values, ladies and gentlemen, is exactly the same as for your sine graph. Now remember what I did when we graphed that sine one in the last video. I started out by calculating the phase shift or the displacement, and whatever that is, remember, that's going to go in right there for your very first x. That's the first one. And then the distance from point 1 up to point 5, of course, is going to be one complete period, one complete cycle. We divide that into 4 because there are 4 intervals from the first point to the last point. 5 points, but 4 intervals. And then we just add on the period divided by 4 to the phase shift 4 times. All right, so let me see. What is the phase shift? Remember now, that's negative c over b. I'll show the calculations here. All right, I'll show the calculations there. Now, here's your c. C is negative pi, right? So this is going to be negative negative pi, divided by b is that number right there, 4 over 3. Now be careful. Be careful here when you're dividing with fractions, because that can be really tricky. This is the same thing as pi, positive pi now. Divided by 4 over 3 is the same thing as multiplying by 3 over 4. You see that? So you're going to get 3 pi over 4. Let me just check that and make sure. Yep. That is your phase shift. Let me write that right here. 3 pi over 4. That very first maximum, that starting point for your cosine graph, has been moved. It has been shifted, phase shifted, 3 pi over 4 units. And because it's positive, it's to the right here in this case. So that goes right there. Look at that. Now you could plot your very first point right now if you wanted to. 3 pi over 4 and 2/3. Okay? Now, I'll erase those workings right there. Now, if you're writing this down, you can pause the video to make sure you get those workings written down. But I'm just going to erase those now because now I've got to get my period, and I've got to divide that period by 4, and that'll give me my distance between points. All right, so let me see. I'm at this calculation right now, right there. B, that's the number in front of x, is 4/3. Okay, so the period, I'll just put the calculation down here. The period is always 2 pi on the top, divided by b, which in this case is going to be 2 pi divided by 4/3. Now again, be careful, you're dividing there by a fraction. So this is going to be the same thing as 2 pi dividing by 4/3 is the same thing as multiplying by the reciprocal, which is 3/4. Okay, so you take that and you multiply it, you get 6 pi over 4, which is 3 pi over 2. Now that's the period. That's your period. So let me put that up here. 3 pi, that's supposed to be a pi, 3 pi over 2. That's my period. And there's the calculation for my period right there. So again, if you're writing this down, you can pause the video and put down those workings there. Okay, a little bit of working involved, isn't it? So now let me erase this. Now remember, that's not the distance between points, though. That's actually the distance between the first point and the last point, not between adjacent points. So I'm going to do a calculation here now. Watch this. I like to call this the distance between points. The distance between points is equal to the period, whatever that is. I think we know what that is. And you're going to divide that by 4. So the period is 3 pi over 2, and you're going to divide that by 4, which is the same thing as saying 3 pi over 2. 3 pi over 2. Dividing by 4 is the same thing as multiplying by the reciprocal, 1 over 4. And look what you get. Ta-da! 3 pi over 8. Now, that is what you add on 4 more times. So I'll tell you what, I'll just come up here and I'll put down I got to add on 3 pi over 8 because I'm trying to make some room for myself here. See that? There's my distance. That's the distance between the points. And that's what I'm going to have to add on now 4 more times, 4 separate times. Okay, so you can see the calculation that was involved there. The period divided by 4. And now all you got to do, and like I was saying, most of you will probably do this with a calculator. At least it's not likely you will make an error by using the calculator. Okay, so that's what I add on now. So let me see. Here's point number 2. Here's point number 2. My x value number 2, I should say. So point 2. I already know what the y value is, you see. So we're starting at 3 pi over 4, and I'm adding on 3 pi over 8. Okay, now like I say, you can do that with a calculator, or you can get a common denominator. Common denominator there would be 8. So the first term would become 6 pi over 8 plus 3 pi over 8. And I'm pretty sure that's 9 pi over 8. 9 pi over 8. Uh, I've actually had students, and I've kind of recommended this at times. Remember that down in the graph, right here, we said that each block was pi over 8, right? Well, if you left all of these x values with an 8 for the denominator, you can easily tell how far left or right you have to go to get to that x value. So for example, 9 pi over 8, remember now each block is pi over 8, so I would just start at the origin, and I'd go 9 blocks to the right. There you go, right there. You see that? That's 9 pi over 8. 3 pi over 4, well, think of that as 6 pi over 8. So again, from the origin, I'd go 6 blocks to the right. 1, 2, 3, 4, 5, 6, and right there you go. There's your 6 pi over 8 or 3 pi over 4. But you see you're going to have to be moving. Now, between adjacent x values, you're going to be moving 3 blocks to the right. And that's going to be happening all the time. All kinds of little tricks if you think about it carefully. Okay, number 3. Here's get point number 3 here now. All right, now like I say, if you wanted to leave that as with an 8 denominator, you go right ahead. So we've got 9 pi over 8 plus, remember we're adding on 3 pi over 8. So let me see, 9, 3, that's going to be 12 pi over 8. Now if you wanted to put that in for your x value for point number 3, you go right ahead. Because that tells me now that down here in my graph, I'm going to have to start at the origin and go 12 blocks to the right. And that should take me right up to 3 pi over 2, shouldn't it? Yeah? Well, you reduce that. You reduce 12 pi over 8, divide them both by 4, and by golly, you're going to get 3 pi over 2. Okay? Or like I say, you can leave it 12 pi over 8. For point number 4, 1, 2, IV. If you're used to Roman numerals, if you're not, don't worry about it. Point number 4. Okay, we started out with 12 pi over 8. That was the last one. Okay, or 3 pi over 2, whatever you wanted to call it. And I'm going to add on 3 pi over 8 once again. All right, so that would be 12 pi over 8 plus 3 pi over 8. I'm pretty sure you're going to get 15 pi over 8. So that would be 15 blocks to the right of the origin. Even though you can't see you won't see 15 pi over 8 there, but if you go 15 blocks to the right of the origin, that should take you right to there. 15 pi over 8. Now, of course, you go up one more eighth of a block, or 1 block. If you add on pi over 8, you're going to get 16 pi over 8, aren't you? And that's 2 pi right there. 16 over 8. And so that's 15 pi over 8. And if you do the very last one, I'll just give you the last one, what it is. You'd have to take 15 pi over 8 and add to that once again 3 pi over 8. I mean, you see what you're going to get. You're going to get 18 pi over 8, aren't you? And you can leave it as 18 pi over 8, or you can call it 9 pi over 4. 18 blocks to the right of the origin. Okay, let's come down. Let's see if we can graph those points here now. See if we can graph them. Okay, so the very first point we had was 3 pi over 4, which remember now is 6 pi over 8. 1, 2, 3. There's your 3 pi over 4. It can be confusing, I'll grant you that. There's your 3 pi over 4 right there. And the y value was 2/3. So that's right there. There's your point. There's your very first point. That's the first one. The next one is 9 pi over 8, which was right there. 9 pi over 8. And now the y value is 0. You see, we started with a maximum this time, didn't we? Now, do you see the pattern there between your points, between your blocks, between the x's? You're basically 3 to the right and 2 down. Well, by golly, you go 3 to the right and 2 down again. As long as you're sure those first two were correct, there you go. There's your next point. right? And you look at it, 3 pi over 2 and negative 2/3. By golly, that's it. The next one was 15 pi over 8, so that's 15 blocks to the right. That will take you right to there. There's your point number 4. And the next one, the last point, is going to be another max. Now, let's go back and make sure. Did they ask us for 2 cycles this time? No, example number 3 just said sketch the graph of the function. It didn't say 2 cycles. Well, in that case, 1 cycle is sufficient. Okay, you can graph 1 cycle. So 9 pi over 4, which is 15 pi. 9 pi over 4, no, sorry, 18 pi over 8. So if you go 18 blocks to the right, you're going to end up right there. There's your x value. And up. There you go. There you go, ladies and gentlemen. There's your 5 points. You see that? Max, 0, min, 0, max. And that's the difference between graphing sine function and graphing cosine function. So watch, now I'm going to join this up. Now remember, no teeth. This is not, yeah, you don't want it that sharp. You'll cut your finger graphing it. So you come up, kind of like that. Now make sure you show that these 2 points are on the ends. Make sure you show their maximums. So like, just continue on like down like that. And over on the left side, same thing. So there you go. That's fine. That's absolutely fine. That is one complete cycle of this cosine graph right there with all my messy marks around it. We've got it. But the x's, you calculate the x's in exactly the same way. And basically, you can use your calculator. You can just let your calculator do the hard work. And then you go ahead and graph them, plot them. Now, there's some practice questions that you should try. Page 29. Now, you'll notice that one. Look at it carefully. That's a sine function. There's another one on page 30. And that's another sine function. Okay. And I think there's one more. They've got the graph paper there. Different scaling sometimes. And there's one more on page 31, and this one is a cosine function. So you try those. Remember to keep checking the solutions on D2L. And if you have any problems with anything, you just pop me an email, and I'll get right back to you, okay? Probably set up a private Zoom meeting or something. We can go over this. Anyway, I'll stop this video there, and I think, if I'm not mistaken, we have maybe one more video left to go. And the next lesson is going to be on, remember what we've done the last 2 lessons. I've given you the equation, and you've had to draw the graph. Well, the very last topic is, what if I gave you the graph, and I asked you to come up with the equation? So that's finding the equation from a given graph, and that will probably be our last video for this unit, okay? So I'll stop there, and I'll see you all later. Bye-bye.